In this video, I am going to go through question 7 from the homework task. And this question was taken from the exam in 2009, and it was question 1 in that exam. And the question is, I will put a picture of this below. The question says, there are 3 posts, P, Q and R, fixed in that order at the side of a straight horizontal road. So here's my road across here. The distance from P to Q is 45 metres, and the distance from Q to R is 120 metres. A car is moving along the road with a constant acceleration of a metres per second squared. The speed of the car as it passes the post P is u. So that's the speed of the car as it goes past post P. It passes post Q 2 seconds after passing P, and it passes R 4 seconds after passing Q. And the question is, find the value of u. So we've got quite a lot of unknowns in this problem. But what I'm going to do is I'm going to first just focus on the section from P to Q. So all I'm looking at is going from P to Q, this bit here. Now let's write what we know. S, the displacement from P to Q, is 45 metres. I'm taking this direction as being my positive direction. Quite obvious that I was going to choose that to be my positive direction, otherwise I'd be working backwards the whole time. So from P to Q is 45 metres. The initial velocity, so the initial velocity of the car when it's at P is u. We were told that in the question, u metres per second, and we are trying to work that out eventually. That's what we want to find. The final velocity is the velocity at Q. I don't know this, and I think I want to work that out. A, the acceleration of the car, is just given as a in the question, a metres per second squared. And the time taken from P to Q is 2 seconds. Now, there's a couple of different things I could go for here. What I'm going to say is that, what do I want to use? I don't really want to take into account A, the acceleration. So I could use S equals U plus V over 2 times by T. If I rearrange this, let's have a look, what do I get? I get that 2S divided by T, take away U, is equal to V. So V, oh, this looks like it's going to be very complicated, equals 2S, which is 90, divided by 2, so it doesn't really matter, 45. 45, take away U. So the velocity as the car goes through Q here is 45 minus U. Now let's look then at Q to R, that part there, Q to R. And do the same thing for section Q to R. So the displacement from Q to R is 120 metres. The initial velocity is the velocity at Q. Now this is 45 minus U. The final velocity, I'm not sure. Let's try and work that one out. The acceleration is a metres per second squared. So let me put the units on this one, metres per second there. And then the time taken is 4. We were told that in question, 4 seconds. And let's do the same thing as before. So we said S is equal to U plus V over 2 times T, and we rearrange that to get that V is equal to 2S over T minus U. So V here is going to equal 2S over T, so 2 lots of that divided by 4, well, that divided by 4 is 30, times 2 is 60, minus 45 minus U. So if I minus 45 minus U, that's the same as obviously adding U there, so I get 15 plus U is the velocity as the car goes past R. So let's have a look there, 15 plus U. Now I think there's a couple of different things we could do here. Now I'm going to look at the journey from P all the way to R. So let's have a look at that. P to R. The displacement is, well, 45 plus 120, so 165. The initial velocity is the velocity at P, which is U, metres per second. The final velocity is the velocity at R, which is 15 plus U, metres per second. the acceleration is a, as it has always been, and the time taken is, well, it took 2 seconds to do this bit and then 4 seconds for that bit, so that's 6 seconds to go from P all the way to R. Now I know that S is equal to U plus V over 2 times by T. And if I put all what I've got into that formula, then I hopefully should be able to solve for U, which is what I'm looking for in this question. So S is 165, U is just U, and V is 15 plus U, so I end up with 15 plus 2U, all over 2, multiplied by 6. So I can rearrange then to work out what U is going to be here. So let's see, what should we do? If we do 6 divided by 2 here, it's going to give me 3. So I can just say 165 divided by 3 minus 15, that'll be equal to 2U. If you need to do this in a longer way, then that's fine. Just check that you can get down to my answer for U here. So U is going to be equal to 165 divided by 3 minus 15, all divided by 2. Let's see what we get for that answer. I'm going to type that in, back on the equation. So I'm doing 165 over 3 minus 15, and then dividing my answer by 2. So I should get 20 meters per second, and that is what U is equal to. So to be honest, I wasn't really sure when I started this question exactly where I was going with it, how I was going to work out U. But what I did was I split it down to each of its parts. So I first looked at from P to Q, I then looked at Q to R, and I finally looked at P to R, and I was able to find an equation where my only unknown was U. So I could solve then to find out what U is equal to.